Welcome everyone to the short presentation about open source, mainly gaming handhelds, but they are not only made for gaming, as you will see during my talk. I will first start with a bit of a history and of the Pandora, which is a device which I have been worked with as well, designing it, and then about the successor that will probably be finished end of the year or early next year. At least the prototypes, the final ones. So, and I will give you a bit of information about the status, about the changes, whatever there is. You're free to ask questions anytime during the talk. If you just have a question, raise your hand and I will ask you. And, well, let's just start first. I'm Michael Mrozek, or Evil Dragon is known in the community, so if you go into the internet and look for Evil Dragon, you will most likely find me. Let's first start with the GP32. That's that little Korean handheld from 2001. Does anybody know about the GP32? Anybody had one? Oh, not really. I know there was a French community about it, but it wasn't really an open source handheld. It mainly was made as a commercial handheld by a small company from Korea, and it should have been a competition to the Game Boy Advance. But I don't think they released more than 10 games for it. And what's great about it, it was a bit more powerful than the Game Boy Advance. It used an ARM processor, and I don't know if anybody remembers these cards. Those were smart media cards, which were the common cards used before SD cards or compact flash cards in cameras. So the GP32 had the advantage that it used a normal smart media card, and of course that attracted hackers. The firmware was opened within a few days, basically, and then people were were able to run homebrew and their own stuff on there. So even though it was a closed source handheld, the community opened it up, and that basically opened the way to the first handheld that was really open source, because that was the GP2X. The GP2X was made by the same people from the same company, and as they saw that the GP32 sold better thanks to the homebrew community, they decided to focus on open source, not locking down the system or the community. And so the GP2X was the first handheld to really run Linux, the first gaming handheld. And it also was the most successful open source handheld out there. Back at the time, 2005, there wasn't much out there. There were homebrew communities later for the PSP and for the Game Boy Advance, but of course that's completely different than having a real Linux handheld. With real Linux, we have to say the devices always had small Linux firmwares. Of course, the resolution was 320 x 200. They were mostly used for gaming, so there was no X server or anything. It used SDL and the standard Linux libraries, but of course there was no real X server or desktop environment. That followed later with the Pandora, which was a bit of a split of the handhelds. Pandora is, if you haven't seen it, this little, mini PC, basically. It's a mixture of a PC and a handheld gaming device. You can see it, well, yeah, it's a bit dark, but you can see maybe on this one, it's got gaming controls. You've got analog controls as well. You got buttons, you got a full keyboard, and it's the first open source handheld device to run a complete desktop environment, in this case XFCE, in a Pocket environment. So it opened up a lot of possibilities. I was one of the developers, and at the beginning we only thought about it as a real successor as a gaming handheld. So the keyboard was there because we wanted to emulate DOS games and an Amiga. This was also the reason for a touchscreen, so we can use a mouse on there. And of course we wanted to use Linux because ports are easily possible. But quickly after the prototypes have been released, we found out that this thing is actually powerful enough to run a full Linux environment and have a standard desktop there. So you've got Firefox, you've got ClawsMail, you've got Thunderbird, whatever you like. You can run LibreOffice, you can use it for gaming and for working. And that opened a lot of possibilities. Of course, there still were other gaming handhelds, and there still is, for example, the GCW0, which is also an open source Linux handheld, but it doesn't have a keyboard or an X server, it's just for the quick gamer. So basically, in 2008, when we designed the Pandora, the market split in two a bit. There was a device for people who wanted to play games and have a PC, and there was a cheaper device for people who only wanted to play games. And that's still to date. Let's talk a bit about the Pandora first, because the Pira, which I will be talking about shortly, derived from the Pandora. There was a core team consisting of 5 people. One of them was me. 2 other were the distributors of the GP2X in Turkey and in UK. Then we had 1 hardware designer and 1 case designer. The complete system was created based on ideas from the community. We were not just selling the thing, we were active members of the community. And so we were talking with them, we were discussing about what could be made better from the GP2X, what could be enhanced. And so the first ideas of the Pandora arrived, and well, we started to create it. And after a long time, after a long journey, it worked out, and we now have the Pandora running stable. It was the first open source handheld to run a Linux desktop with standard libraries. So you've got your standard SDL, X, ALSA. We also got Mono right now, Java. So everything you've got in a standard environment is available on the Pandora as well, which is great because if you want to compile a game, all you need to do is download the source code, run your configure, do your compile, and then you've got the program running most of the time. Small fixes maybe because of the screen resolution, but for most programs this was simply working. So porting a game from a desktop PC to a small handheld PC was very, very easy. Well, there was a lot of production issues with the Pandora, partly due to our inexperience. We have never done something like that before, so we had no idea that there are parts where you have to wait for 12 weeks before you can even get them, and that it takes, for example, 6 weeks just to get a simple PCB made, and that delayed things a lot, especially with the case, which has been produced in China, and trying to speak with China or with Chinese companies, explaining them what you want, and then just being a small company, because for a Chinese company, the minimum order quantity usually is 100,000 cases and up. And we only wanted 5,000 to 10,000, so we were a small fry. That took over a year just to get the case done. So we had a lot of production issues. Release was planned for end of 2008, and in reality it happened 2010. But thanks to the great community that stuck to us, we managed to get it going. One other problem was about 2011, the project nearly died thanks to one of the core members. One of the core members, well, he was the main guy behind the Pandora. He had the idea about the Pandora and he started it, but he was mainly interested in making money. He was not interested in creating a device for the community, working with the community, but he wanted to work with the community actually to make money. And due to the production issues, there wasn't really any money made. In fact, a lot of money was lost, I think about 300,000 euros. So I saved it with investors from the community and a strong community behind it. Moved the production over to Germany. I'm now in charge of the production, and since 2011, over 7,000 units have been sold and delivered, and production is stable, running basically in a company just around my corner. So that was also one of our parts of inexperience. We were looking for the companies worldwide, and now I'm trying to have the companies near my own place, because if you have any discussions with them to do about production, about development, then it's easier. You can just meet them and talk about it, and you don't have to travel to the end of the world. Well, the Pandora will see the end of life in 2014, simply because some parts are impossible to be sourced anymore. That's another problem you encounter when you're working with hardware. Hardware electronics is evolving fast, so after a few years you can't get the parts anymore. The technical details about the Pandora, if you don't know them, it has an OMAP 3 Cortex-A8 CPU, which is faster than the Raspberry Pi. Slower than modern smartphones, of course, but well, modern smartphones are usually slower because of Android. So if you run some emulators or games on the Pandora, they usually run faster than on a Cortex A9 Android device, simply because there's not so much running in the background. But Android devices aren't made for gaming, in my opinion, anyways. So it got Bluetooth and Wi-Fi, 512 megabyte internal memory and internal RAM, which is not much these days, but it was enough for a small operating system. It got a 4.3 inches touchscreen, but you can also use the analog controls as a mouse. It got 2 SDXC card slots, and that's the important thing. Even though you only have 512 megabyte inside the device, you can put up to 2 times 256 gigabyte SD cards in there, and then you've got 512 gigabyte storage, which should be enough for such a small device. What's also special about having 2 SD card slots is you can boot your operating system directly off the SD card, which means you can run other distributions like Debian or Slackware, even Android or RISC-OS. There are a variety of different operating systems available for the Pandora, and you can boot them from the SD card and still have a second card, second slot free in case you want to view pictures from your camera and just plug in the SD card. So this was a way to get around the limitation of the internal NAND as well. Then also, well, standard for a PC, but non-standard for a mobile device, you've got a normal mini USB port and a USB 2.0 host port, which means you can use the Pandora as card reader if you like. You can use it as a keyboard or gaming controls for other devices. Of course, you can also connect USB devices to the Pandora. You can program the Arduino. I think you can even 3D print, work with some 3D printers. You can use it as a synthesizer for music production, so I know there are a lot of people doing anything I never imagined would be possible with this device, and that's of course also thanks to standard ports. We also got an analog TV out. So if you got a classic TV at home, or if you are going to a hotel, which I did a few times, I've got the Pandora with me connected to the TV. Then you can either connect also a keyboard and a mouse, use it as a desktop PC, or just play games with 1 or 2 players on a TV or few movies. So when I go to holidays, I usually never have another device with me anymore because, well, it does anything I need. As seen, it got a keyboard and gaming controls, which is getting rare for today's mobile devices because everything is just only a touch screen that doesn't really work for me. And it also got a replaceable battery with more than 10 hours of usage time. And more than 10 hours really means more than 10 hours. During the last days, I think I had a battery time of 14 to 15 hours because I was just replying to emails which didn't use much of the CPU time. So just listening to MP3s with a light switch off and something like that, with no, when you don't use the display, I think you have about 60 or 70 hours of MP3 listening time. So yes, it really got a huge replaceable battery, and you can even use it to charge your phone if the phone runs dry, which is also pretty neat because phones usually these days half a day and they're empty. With a Pandora you can recharge them. Well, the main users, as said, it was a pretty flexible system. We didn't know at the beginning what it will be used for. We created it for playing classic games and homebrew games. But a lot of things have happened around the community. As mentioned, you can play classic games via emulators, consoles, computers, handhelds, DOS, up to PlayStation, a bit of Nintendo 64, Nintendo DS, Amiga C64, everything is working. So all your favorite childhood games can be emulated. You can of course play native Linux games and ports remakes. And to be honest, during the last years, there are many great free Linux games that have become available. And for me, they're often better than a lot of commercial games that are released these days. You can also use it as a general purpose mini device, internet, administration, office work, music production, well, whatever you can think of. You can develop and compile directly on the system, which is also neat. You don't need to set up a cross-compiler. You can just run, as mentioned, configure and make, and you can of course also run IDE, for example, CodeBlocks is available, and then you can just directly develop on the console. One thing that was important for us is that it's both suited for normal users and developers. It's completely open, but that openness also means that some people, it can be too much to get it working. So we created an operating system based on Open Embedded where you don't need any Linux experience. Everything is pre-installed, so you switch on, have a small wizard where you just enter your name, set some parameters you would like to automatic logging in and such things, and then it boots to the desktop. And also we have a package manager which easily works. You just connect to the internet, select the game you want, install it. You don't need to register anywhere, so nothing like the Google Store where you need to give Google everything you know about yourself. It's like a classic PC. You switch it on, you can use it. You don't need to use the package manager if you like to. You can even go on a normal PC to the internet, download the game you want, copy it on an SD card, and it runs. So you've got a system there that works for everyone, is easy to use, and which opens up Linux for a large community. That's of course also the reason a large community has developed around it, with all kinds of different members. If you go to the boards, you will meet developers, musicians, users, gamers, retro fans, a really, really wide variety, which is also fun because they are all discussing, which is also great. Well, having created the Pandora, there are of course things that can be improved. You always find that out later. Some things can be improved because when we designed it, that was 2008, it's now 6 years later. A lot has happened in the mobile business there. The mall is a bit, the NAND, the internal storage, is a bit small. So we need a special Linux distribution, as mentioned, based on Open Embedded, which means it's a lot of work to keep all the packages up to date. We're still using XFCE 4.4 and Qt4 in older version because it's nearly impossible with the small manpower to keep all the packages up to date. Well, a workaround, run your own operating system from SD card, as I mentioned, Slackware, Debian, anything, Arch Linux, where you got new packages, but for the default OS, that's a bit of a problem. And we had to create an own easy-to-use package format, which is, in my opinion, a good thing because whenever you have a distribution, you've got great package managers, apt-get, Pacman, whatever, but they have one problem for mobile devices. They install all the files on the root file system. You can work around with symbolic links, of course, and it has a database where it keeps all the packages and programs that are installed. If you've got a mobile device with SD card, what happens if the SD card gets lost, is broken, anything like that? With a package manager, you have a broken system, and you would basically need to reinstall the whole base OS because it doesn't find the files that it expects, and you will have a complete mess. That's why we created that own package format. I will talk about that a bit later. And this works with mobile devices. I can simply remove the SD card and then all the programs will be gone. As soon as I put it back in, all the programs will be back there and running. So it's working in real time. Just remove it and put it back in and it works. Well, these days the CPU is a bit slow for demanding tasks. As mentioned, Firefox runs, but depending on the website, it can really get slow. 6 years ago, it was a state-of-the-art CPU. These days, it's a bit slower than phones. So that could need an upgrade. Also, for proper desktop usage, there's not enough RAM. You can set up a swap file, of course, but that will slow things down even more. There's no HDMI port because back then nobody was using HDMI. The keyboard can't be seen in the dark, so it doesn't have any background lighting. It's just labels printed on, and if it's dark, you don't really see what you're typing. The screen resolution is less than 800 times 600, which is a bit of an issue, not a bad thing. The programs work, but if you run any Linux X-server program, they usually expect 800 times 600, which means you always need to scroll down the windows or move the windows up and down to access all the buttons. The case quality, as it was made in China and at a very cheap company, is not the best. The knob quality, so the analog control quality, is not the best either. And we've got some closed source drivers, for example, Wi-Fi or SGX. This would be great if that could be all improved. Let's first take a look at of the things that are great. The size and the battery life, the combination of keyboard and gaming controls. Everybody who has one and got it with him always, you can just, I can even put it in my pocket here, I can put it in my trousers. And with a long battery life, as mentioned, I don't need anything else. And I think a lot of the members in the community do the same thing. It's also good that it's a standard Linux system. No special development environment needed, just compile and run. I'm also happy that it has an analog volume wheel, because I actually don't like all these digital and on-screen display volume controls. I just want to move it down and it should be switched off. Standard I/O ports, USB and all that stuff. Open, free, flexible and no registration needed. Unbrickable design. The bootloader is simple U-boot, and regardless what you do, you can mess around in the unit as much as you like. You can always create a bootable SD card which will restore it to the standard environment. So you don't need to be scared to hack around with the software and to brick it. And next thing, the P&D system, that's the system I mentioned with the packages on the SD card. System is not affected if the SD card is lost or broken. The basic system always runs. You only need to reinstall your programs and software, and that's it. Easy to handle, both directly on the system or from any PC. And what's also good is that it has a standard hardware. So every Pandora basically is the same, while we got 3 different versions, but they're not that much different, only the CPU speed and the RAM basically. But anybody who codes software for this one or ports software optimizes it to run perfect on the system. This is a big problem with Android, in my opinion. There are so many Android devices that game developers have to take care of the resolution, of the CPU speed. You don't know if you buy a game for Android, will it run on my device, will it run nicely, will it need a higher resolution, is my CPU fast enough? So having here a standard like with the PS Vita or any other gaming device, the coders, the developers can concentrate on the system and optimize the software to run perfectly on that system. Let's move on to the Pira, which will be the next incarnation of the Pandora, because as said, the Pandora will most probably, well, not being produced anymore after 2014. We've already got some prototype cases, but I will tell you more about the current status later. The internal storage will be upgraded. It will be possible to use an internal micro SD card. So whenever you want to run your own operating system, no need to touch the internal storage, just plug in your internal micro SD card with whatever size you like and you can run it. And it will have 8, 16 or 32 gigabytes internal storage. 8, 16 or 32, not because we want to make different versions available, but we don't know yet which one we will use. eMMC usually is replaceable, which means while we are developing, we're probably using 8 gigabyte storage, but it always depends on the price. If next year the price for the 32 gigabyte storage is pretty low, then of course it makes sense to use the 32 gigabyte one. We'll see that when the device is finished. The CPU will be upgraded to an TI OMEP 5 Cortex A15, which is about 8 times as fast as the current Pandora one. So there's a lot more running. I can later demonstrate a bit what you can do with it. We will have a standard HDMI port, which is also great because when you come at home, you connect mouse, keyboard, plug it into your TV or monitor, and got a full HD desktop environment running. So replaces your PC for small tasks as well. And we are also planning to create a docking station so that you just come home, put your Pira in the docking station, switch on the monitor and have your PC running. Pretty neat feature, and wow, that's all possible. Then we will have a backlit keyboard, which will also be a great update if you're often typing in the dark. A 5-inch screen with 1280 x 720 resolution. We also tried a full HD display, but honestly it's just not worth it. The icons are so small, you need to increase the complete icon and text size. It uses a lot more CPU power simply because you need to render at a higher resolution, and for that screen size, 1280 x 720 is totally okay. I still have no idea why mobile phones are now starting with 4K screens on 5-inch or something like that. The NUPs will be better. The case is being designed and produced completely in Europe, so we can visit the company, we can discuss any issues with them, and they will take care that the quality is a lot better than with the Pandora. We will have some more standard ports. In fact, we will have 2 USB ports this time, 2 of the large ones. One of them will be an eSATA combination, so you can also connect an eSATA hard disk if you like to. We will have a micro USB 3.0 OTG port and another micro USB debug and charging port. Debug port means you can connect a standard micro USB cable to your PC, and it registers as a serial device on your PC, so you got the serial output directly from the processor. So if you want to do some low-level kernel debugging, you can do that without needing any extra hardware. One thing we learned from the past is that we're trying to work with European companies to ensure the quality and faster turnaround times. As mentioned, sometimes with the Chinese case designers, we needed to wait 2 to 3 months just to get a new case revision. And with a company in Greece, usually I tell them the changes and get the new case version 1 week later. So that's a huge difference. And that's something that really had to be improved. Well, the problem is we still will have some closed source drivers, at least the 3D driver, but the only open source 3D driver available is for Intel chips, but as soon as you use Intel chips, you need to use design your own BIOS chip and stuff like that, which is a lot more complicated with all that UEFI stuff and things like that. So not only designing the software, but also having to design the hardware around it is just not possible. But one thing we learned, which is good about the SGX, is it's just the 3D driver itself that's closed. The kernel part is open, so you're not stuck to an older kernel simply because of the 3D driver. You can update your kernel and just use an older 3D driver version. Is that a question or? Okay. So basically the idea we had behind the Pyra is keep what's good and improve what can be improved. And of course learn from the past to improve development production and not repeat the same mistakes again. So we really gained a lot from that and learned a lot from that, and well, let's see a picture where you can see a bit of the differences. The top key row had been moved further back, so we've got now 4 keyboard rows there on the Pyra. They're still comfortable to use. If you want to test it out yourself, you can try the prototype case after the talk. And we also had to move it down because the speakers, you can barely see them on the screen, the speakers were moved down from the top into the bottom of the case. The speakers are also improved. They are specialized speakers which need an acoustic surrounding which has to be taken care of. So it will be a lot better from the sound quality than on the Pandora. And it also enabled us to use a bigger screen. So the size of the Pyra is the same, but the screen is a lot bigger than before. We moved from 4.3 inches to 5 inches. The knobs have been changed, as I mentioned, but basically keep what's good. The size and the form factor is the same, but these parts have changed. As an operating system, we now got more storage. We will probably stick to a standard ARM, Debian ARM, with optimized packages to support hardware features. We've got standard Debian running on the dev board here. I can show you in a few minutes. And you will see that the moving around Windows on the X server is terribly slow, which is simply because it doesn't use any hardware acceleration yet. Debian is created to be compatible with any device, and the Tegra 2, for example, didn't use any neon acceleration, so that's not included in Debian as well. Yes? The question was if it was ARM or ARM-HF. As far as I'm aware, Debian uses ARM-HF as default setup, and that's what we are using as well. Yes? Oh, Debian offers both. I always forget which was the older one. I think, yeah, ARM is the older, yeah. Then we are using ARM-HF, the most recent one, of course. But the kernel will be compiled to use softfloat as well, because the Pandora is using softfloat, and we try to make some compatibility layer so that the old games will also run on the new system right away. But the main system will run on ARMHF. We will also want to create a user-friendly default setup, so we implement some packages like Iceweasel pre-installed, Thunderbird maybe, or Clausemail. Of course, you can always deinstall them if you like to, but we want to give the non-Linux user, the non-techie user, a standard environment where you can just switch it on and have everything working. Some other useful Pandora developments have happened during the last years, which we will also want to implement. As mentioned, the PND system, which will be needed for compatibility with the old system anyways. And there's also an OpenGL wrapper named GLGIM being worked right now, which enables you to actually run standard OpenGL applications, not OpenGLES, but OpenGL applications on the system, directly on the Pandora. We want to include that into the PIRA, so with increased compatibility, you will have a mobile device which features standard OpenGL and not just OpenGLES, which is a neat thing as well. So we will provide our own repository with PIRA optimized specialized stuff, and that is all on top on the standard Debian repository. The goal is not to create a custom distribution. A custom distribution just means you have to do a lot of work yourself. Maintaining it, all the packages is just a lot of work. And having a standard distribution or sticking as close as a standard distribution is useful as well, because all the packages that are there for Debian ARMHF are available right away with just an apt-get command away. The case, as mentioned, is being designed in Europe, in Greece. It's based on the Pandora case, that's why it looks pretty similar, and it's also based on community input and ideas. For example, 4 shoulder buttons was something the community wanted to have, and we're now working on implementing them. 6 face buttons is something the community wanted. A larger screen was something that came from the community, and I always thought, well, why not? Let's see what we can do, and so we are working together with the community to create an updated device that's better in every aspect. The current status of the case is, well, as you can see, the basic design is finished. We already have a PCB in here which fits, but it's now being optimized together with the PCB designer. The reason is, on that PCB, we will change some things compared to the Pandora. The Pandora was just one PCB where all the parts were on. On the PIRA, we want to have a special CPU PCB. So this will just be a simple PCB with all the needed controllers, Wi-Fi, keyboard controllers, and SD cards on. It will be as simple as possible, maybe even a 2-layer board. So we need to work together with the case designers to be able to move the parts to locations that it will also work, that both the case will be stable and both the PCB can be created as simple and cheap as possible to not increase the costs. And then we will have the PCB design, but PCB and optional PCB board, which I will talk about later. Some things will still change. For example, the LCD, we're just currently testing which will be the best LCD we can get. And we will also test various batteries to see if we can improve the battery life by using an even larger battery. So these things will have to change, but apart from that, the case is basically finished. So that should be no problem when we go into mass production. The keymat is currently being designed. It will look similar to what you can see here. It will be a transparent base material with plastic keycaps on top. So it will feel much better than the Pandora keyboard. It will basically be similar to a mixture of a laptop and a mobile keyboard. We will also take care that the keys are easier to push, that they feel great, and with transparent silicon transparent keymat and the plastic caps on top, it will feel like a real high-quality keyboard. The PCB, as mentioned, the PIRA has 3 PCBs. One is the main board. Then we got a replaceable CPU board, which will go here. There will be small connectors where you just plug on the small CPU PCB. So this means the PCB is replaceable, and I will tell you why in a few minutes. And we will also have an LCD driver board in the back, which means that if for some reason the LCD we're using is not available anymore in a few years, all we need to do is change the LCD PCB. Nothing in the main area needs to be changed, and then we can use a new LCD as well. So trying to work around the issue that some parts might not be available anymore in the future. That's why we are using different PCBs. The main board is basically finished as well, as mentioned, together with the case designers currently being tweaked. The LCD driver PCB is also finished. Well, that's nothing complicated. It's basically just a PCB with a few connectors and an LED. And the CPU PCB, which will be the most complex one, of course, the size and location is finished. So the case designers know exactly how much space we need for the PCB. And the layout for that will start next month, this month. It's already July, yes. Well, some information. Let's first get to the CPU PCB. There are two reasons we wanted to have it replaceable. The first one is production is easier if the complex PCB is smaller. So we can produce more CPU PCBs with one go, which means it will be cheaper to produce them. So this is to reduce the costs quite a lot, from basically 20 euro per PCB to about 8 euro per PCB. So this will lower the costs for the PIRA. Another thing is, right now with the Pandora PCB, if something is wrong with the SoC, so the processor, which is the most complicated part to put onto the PCB, if something's wrong, we have to throw away the complete board with all the parts on there, so 170 euros lost. If something's broken on this PCB or the CPU one, you just throw the small PCB away that's not working, replace the other one, and then you've got a less costs and a smaller failure rate than before. And of course, if the CPU board is replaceable, and there's a new processor maybe coming out in a few years, which will be attractive for Linux or for an open source device, then the user, the customer, doesn't have to rebuy a completely new device. All he needs to do is buy a new CPU board, which is of course a lot cheaper without the LCD and everything. Open up the backside of the unit, replace the CPU, and voila, you got a completely new system. So these are the three main reasons we wanted to do that. Of course, since we're opening all the schematics and the Gerber files and the case files, maybe some other developers can pick up, create their own SoC PCBs for development boards. So maybe we will have a standard at some time where we can interchange different CPU boards. There's a lot of movement happening with ARM and Linux right now, so we will see where it will all lead. Well, you can also follow the development. As mentioned, the development completely happens in the public. I've got a blog set up, and I've also got a Twitter account for small news in between. And everything that's happening is being posted there. So we're not doing this behind closed doors. You don't have to wait until the device is finished. You can follow the development anytime, see what's the status, what were our ideas about that. Sometimes you can even help out, for example, to find a company that can produce the keymat. I just asked the community to look around for some companies in the internet, and one day later I got 10 different replies and companies which I could check out, and one of these is really the one that will create that keymat. So you can help out, you can follow it, whatever you want to do. You can get as much involved as you like. On pyrahandheld.com, that's at the moment pretty basic site, because the real website is also being set up by the community right now, which has a blog on. And on Twitter, I'm EvilDragon1717, so if you want to follow me and get some small news like, yay, the new LCDs for testing arrived, or something like, here's a picture of the new case I just got in, or the design is finished, anything like that, that's also happening on Twitter. And if you want to join the boards for the Pandora or for the PIRA, that's boards.openpandora.org. So, yes, question. Yes, basically on the website we've got a newsletter, and that newsletter is a mailing list. And we are also setting up a operating system development mailing list right now, as well as kernel development for every developer who wants to help out. And I think for the website we will also set up a mailing list. It will all work via Git and via mailing lists. So any information about that is available on the boards. One of the questions I always get is, what about the availability? What will it cost? When will I get that? Well, we don't know yet. The pre-orders won't start before everything is ready for mass production, which means I want working prototype with the final cases. Based on our Pandora experience, which was horrible, we took pre-orders in 2008 and people had to wait until 2010 and 2011. And well, some people from the other guy who caused issues to the project are still waiting, and we're trying to help them out as good as possible. So I won't take anything, and I won't accept any pre-order before everything is ready, because it's a really complex thing, and you really will run into problems if you take pre-orders before everything is finished. The price itself is not fixed yet, but it will probably start about €500. That's including VAT. So basically the same or even cheaper than your common recent modern smartphone out there, and those probably have a production cost of €100, and we have a production cost of probably €300. So we're not trying to make a lot of profit from that, but we're trying to get a fair price. But with a low production volume, you always have to pay a lot more than other producers. The first batch will be available exclusively from my own shop in Germany, so no problem to order within the EU. In France, I think shipping costs via UPS are 12 or 13 euros, so with insurance, no big deal. But we will also have distributors set up worldwide after that. As for the Pandora, we have a distributor in Japan, in US, in France, and so we will do the same with the Pira. At least 1,000 units need to be pre-ordered, but I think that shouldn't be a big deal. The community has, I think, 15,000 members. There are over 7,000 Pandoras sold, and if we do some more advertising when the prototype is finished, getting 1,000 units out there shouldn't be that big of a problem. So I'm sure it will happen. Some people have asked about Kickstarter as well. I'm not sure yet, but maybe. Kickstarter is a great way to increase the popularity. But with a lot of Kickstarter projects recently that have failed, I'm not so sure if people will like it or not. But I will think about that. We could also offer stretch goals like the docking station or an aluminum case, anything like that. And when will it be available? Well, that's the hardest thing to tell. With the Pandora, we thought 2008, and it was 2010 a few years later. I think it will most probably be sometime 2015. As mentioned, we learned from the Pandora. We are pretty far already with the design, with the basic design. Now, the only thing left mostly is the CPU, PCB, and of course the operating system, the software, which will happen at the same time. So, first of all, thanks for listening. I'm going to fire up the Pyra development board so you can see a bit of what's already running there and what you can expect from the little device. All kind of support, is it ideas, donations, development, sharing is always welcome. So visit the boards, or if you want to get the Pandora, any other open source handhelds or retro stuff, just visit my website, my shop, that's www.dragonbox.de, and we're shipping worldwide and shouldn't be too complicated. So any questions left right now? Then I will just start up the development board. Current status, what you can expect, and I need to switch to the other side. Okay, it's booting. Okay, what we have running on the development board right now is a standard KDE. Of course, you can also run LXDE, XFCE, OpenBox, IceVM, whatever you want. But we've chosen KDE because it really shows how much power that thing will have, because KDE really needs a lot of processing power as well. So standard Debian running at the moment in full HD, so a lot of pixels to push around, connected via H8 DMI. Booting from a micro SD card, not the fastest one, but should be fine for now. Mouse doesn't work too well there. Okay, there we are. Set the standard desktop environment. Let's start GIMP, for example. Takes a few seconds. KDE working as well. File Manager, for example. There you go. I can also start. Yeah, there's GIMP. Let's load an image, for example. So one of the filters that takes a bit of processing power is a Gaussian blur. Let's put a Gaussian blur on there with, let's say 30. Should be enough. So wait a few seconds and there it is. So the CPU power is really impressive with this one. But as said, as soon as I try to move around the windows, it's really, really slow. If you check with HTOP what the X server is doing, I think X is using 70% of the CPU power at that time. So that's completely without hardware acceleration, but that's something that will be changed. We also had to do that on the Pandora. But to show some more, let's, for example, start up console first. So you can see what the CPU is capable of. So first we got a PlayStation emulator. Running without any hardware acceleration as well. Oh, somebody's oversaved my save state. Yay! It's now at game over. Okay, let's just reset the game. At the same time, let's, for example, Pico drive. Some Mega Drive emulation. Emulation always takes a lot more CPU power than anything else, of course, than any other game. So we've got Sonic running here. We've got PlayStation emulation running here. We've got GIMP running there. And we can switch around without any issues. And we still have a responsive system. So I could start any other games. Or any other programs, for example. Well, I've got installed quite a few things. Office, let's, for example, go with LibreOffice. So LibreOffice running as well, all on full HD, PlayStation still running fine. Text document opening, working there as well. So the only problem right now is the slow X server, which will be fixed. And well, you can see all the things that are running at the same time right now, what the CPU will be capable of. And this is something you can have in your pocket next year, basically, with a long battery life and, yeah, connected to your TV screen to to use it as a desktop PC or play some games, or use it on the go. So, if there are any questions left, I think we're near the end of the talk already. Yes, 10 minutes to go. So we've got 10 minutes more for any questions. Of course, if there are no questions, you can also come here, see the Pandora or the Pyra, have some private questions with me if you don't want to ask in the public. Yes, I see a question. I have what? Yes, we have, basically we have for the Pandora a minimal environment which has been especially coded, which is similar to the PSP menu. So you can simply use the D-pad to select the game and run it. Most people these days use the standard desktop environment, but we've got something like that included as well, so it will more feel like a gaming device. Any? Yes, actually, the question was about libretro. Yeah, I know. That's what I'm doing right now. The question was about libretro, about the library, and you're talking about those emulator, the collection of emulators. Yes, I know somebody's already working on libretro for the Pandora. But libretro, the problem is that they are not using all ARM optimized things, so some emulators run too slow, a lot slower than the native ones we've got on the Pandora. But for the Pira, that won't be a problem anymore. So libretro will most probably be available for the Pira as well. And I'm not sure, is libretro available for standard Debian? I think so. Yeah, well then apt-get install, and there you go. Yes, yeah. It's, as said, we will have a standard Debian installation on there. That's one of the great advantages. You don't need to wait until somebody ports it. You can basically install anything you can find on the repository. Yes? Okay, there was a question about the screen, whether it will be a capacitive or resistive touchscreen, and whether it will use IPS or TFT. For IPS or TFT, we don't know for sure yet because we're still testing different screens. But for the touchscreen, I can tell it will be resistive because capacitive touchscreens won't work with small icons. You can only use your fingers, and they are pretty inaccurate. But we're using a resistive screen with a keyboard, with a touchscreen controller, which can simulate 2 buttons. So you can use 2 fingers to pinch and zoom if you want to install Android on it. You just can't. It just can tell exactly where you are pressing. But for most applications, zooming and pinching, that works fine. And of course, single button, it's a lot more accurate than with a capacitive one. I hate the capacitive one on my phone. Put it into my pocket and it does wild presses. Okay, any other questions? Doesn't look like it. Then I want to thank you all again. Follow our development. Feel free to contact me via the internet at the boards. Join the community, and if you have any questions right here, while we are packing everything up, you can always come over and ask some questions. Thanks a lot for your time.